Hi everyone, my name is Thomas Kim. Today is January 21st, 2020. This is my 8th episode about 3D graphics, Intel TBB OpenCL Vulkan. In this episode, we will learn Primality Test and prime counting function. A while ago, I implemented a complete RSA algorithm in C++ from scratch. If you are interested, please double-click this link. In this video, I demonstrated how to implement complete RSA algorithm. To implement complete RSA algorithm, the very first thing I needed is prime number theory and algorithm. For cryptography, I filmed 17 videos. If you are interested, I would recommend this series of videos. Currently, I am not interested in RSA algorithm nor in cryptography. If you are interested in mathematical theories behind cryptography, I highly recommend you Jeff Suzuki's video series. By clicking this link, you can watch more videos about mathematical theory behind cryptography. In my case, I implemented RSA algorithm by watching Jeff Suzuki's Cryptography video series. He explains mathematical theory behind cryptography very well, and I implemented his mathematical theory to C++ code. In this episode, we will implement primality test and prime counting function, and we will also implement a couple or more functions, and we will use them to learn how to use parallel algorithms such as parallel do, parallel invoke, parallel pipeline, etc. in future episode. If you are new audience to this series of video, you have to watch my previous videos. As of today, I filmed 8 videos. If you want to follow my current session and future episode, you have to watch all my previous episodes. Otherwise, you may have difficulties following my current session and also my future videos. Please note that I will not explain mathematical theories behind the primality test and the prime counting function. For primality test, please double-click this link. We will use this algorithm in this episode. Also for prime counting function, please double-click this link. We will use this table, and also we will use this equation. Now start Visual Studio Code. Open your working folder. Please note that we created this working folder in our previous episode. Click this button, 08, Primality Test Counting. Hit enter. Click this button, primes.cpp. Hit enter. Ctrl V. Include talk play fun, output HPP. Include talk play fun, parallel HPP. Include CMS. Include TBB, MALLOC, proxy.h, talk play fun, SS stream, auto, ender, talk play fun, ender. We will create a function, bool is prime, intn, return true, auto, get primes, int max, return 0, int main. If you see these squiggles, Ctrl Shift P, edit, configuration JSON, click this link. You have to set these environment variables. We set these environment variables in our previous videos. Control S, Control W. Then the squiggle goes away. Now I will create one more function. Auto get prime count int max. Sorry, I will change the function name prime count upper bound. Upper bound. Now in your web browser, we will be using this equation. I will copy the link, paste it here. Auto ln x 1 double 1.0 over log x. It is max. Or I would say x. I fixed like this. We are calculating ln x1 equals 1.0 over ln x. So this part amounts to this part. Or ln x2 v square. Okay, so this part is this part. Okay, then auto ln x3 times ln x1. Now return size t x times this part ln x1 times 1.0 plus this part is this part ln x1, this part is this term. Now 2.0 times ln x2, this term is this term, plus 7.59 times ln x3. So we calculated this upper bound. Now this part. From this function, I will copy the link for your reference, and I will copy this part of code. Copy, paste it here. Now we have to translate into C language code. N modulo 2 equals 0 or n modulo 3 equals 0. Then we return false. Or say int I equals 5. This line of code, we forgot semicolon here. Semicolon here. This line amounts to this part. Now here, I times I less than equal to n. It should be block. N mod I equal to 0 or n mod equal to 0, then we return false. Now this part is this part. We can say plus 6. Now we implemented this part of algorithm in this function. Now get primes here, std vector int primes reserve. We have to reserve memory for prime numbers. Now we use this function, paste it here, max for I equals to I less than max. Max is not included here. Plus I if is prime. We are calling this function we defined here. So it should be I. If prime number, then primes in place fact I. Now here return primes. Before we return primes shrink to fit. Now here we display stream capacity primes capacity size primes size, and there. This is for debugging purpose. Please note that it returns vector. Now here void test collect primes or primes get primes. For example, 100 stream primes and there. Now we call this function start command prompt dir cd 08 primality test counting cl ehsc std c++17 primes.cpp fe m.exe hit enter cls m. So these are prime numbers less than 100, 25 primes. Now scroll up. In this table, prime numbers less than 100 is 25. So 25 prime numbers. Now let's try with bigger one. 1000 prime numbers less than 1000. Now we build once again CLS. So 168 primes less than 1000. 168. So it's working correctly. And for example, we will try with this number 10,000, 100,000. We build once again CLS. So 9592. So it gives correct result. Please note that this capacity is calculated using prime count upper bound. This equation gives upper bound. So after resolving the memory, we shrink. Okay? We have to shrink before we return prime numbers. We remove extra space for primes because prime count upper bound returns upper bound, but not exact count. Of course, this is prime function is not much optimized. In future episode, we will optimize this function, primality test function, using parallel algorithms like parallel do, parallel invoke, parallel pipeline, etc. I will upload the source code to my website. By the time you watch this video, you can double click this link and download the complete source code. Please subscribe to my YouTube channel. Thank you for watching.